All right, back for lesson number 10 here, putting atoms together. So last day I talked about how different how our alkalis are very reactive because they want to fill out their outer valence orbit, and so if they lose one electron in the outer orbits, they can achieve that. Likewise, halogens have 7 out of 8 in its outer orbit. If it can gain one more, it'd have a full outer orbit. So atoms basically they want to get together so then they can fill their valence orbits. So we're going to talk about that today. So first of all, a molecule is when two or more atoms join together. So we know water is hydrogen and oxygen, 3 atoms in total join together. Carbon dioxide in the example on the screen there in front of you is carbon and oxygen together. Chemical formula. This is the notation that indicates the type and number of atoms. So oxygen in the air. Oxygen tends to bond with each other. It's what we call a diatomic element. Di meaning 2. So the oxygen in the air around you right now is 2 oxygens bonded together. Water, of course, we know it's 2 hydrogens and an oxygen. And propane, like out on your barbecue, is 3 carbons and 8 hydrogens bonded together. So we use the element symbol, and how many of them there are is the number, and it is subscript. Don't put it up here. It's not an exponent. That's superscript. It's down below. It's subscript. All right, so a molecular element. This is when you have a molecule, but it's all the same thing. So hydrogen is another diatomic. It's just hydrogens bonded together. Here we have ozone, which is 3 oxygens bonded together. Phosphorus, sulfur. So if it's all the same thing, all the same atom type, but there's more than 2 bonded together, those are molecular elements. And 7 of them, as I mentioned before, form diatomic molecules, and there are 2 atoms in each. And our diatomic molecules are hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. Very Canadian here, we call this the hockey stick and puck rule, only because you have hydrogen here, which is the puck, and then over here you have nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. This kind of forms a hockey stick. Use your imagination, ladies and gentlemen. Molecular compounds. This is where we have more than 2 atoms together, but we have different atom types. So you can see carbon dioxide here. You can see one of the versions of sugar, 12 carbons, 22 hydrogens, and 11 oxygen molecules, and hydrogen peroxide, which is you might have that in your bathroom for disinfecting cuts, that sort of thing. And that's 2 hydrogens and 2 oxygens. Only certain combinations are found in nature, so not everything will bond with other things. And some things tend to bond with other things more easily. In nature, we find that we have different ratios of carbon, hydrogen, and oxygen. So you can see here carbon dioxide, sugar. Another version of CHNO will give you vinegar. Another version of CHNO, and when I say version, they have different numbers, different ratios of elements. You get different types of sugar. Change it up a bit here, you get hydrogen peroxide. And so here's a couple of examples. C2H6O, alcohol. Same atom types, but in a different ratio, we get vinegar. And same atom types again, only different ratio, we get oil of wintergreen. It's a flavoring that we use in gum. Ionic compounds. So some compounds are not composed of natural atoms, but made up of charged particles. So here's the scoop. We know that our alkali metals here have 1 valence electron, and it wants to lose that 1. So it'll have a full valence orbit. We know over here our halogens have 7 out of 8. It wants to gain 1. So what happens is this. Sodium, if it comes near chlorine, its one valence electron will jump over to chlorine. Now, sodium normally has 11 protons and 11 electrons. Now it has 11 protons, and because, give me a break, when that one electron jumped, it now only has 10 electrons. This is not my day. So sodium now is positively charged. It has a positive charge of 1 because it has one more proton. Chlorine over here, it has 17 protons, and it normally has 17 electrons, but because it just got one from sodium, it now has 18 electrons. It is now negatively charged. It has a value of -1 as far as the charge. Opposites attract. Positive charged things and negative charged things want to attract to each other. So what happens is sodium and chlorine will attract to each other, and they will bond with each other. They are both happy because they both now have outer orbits, but because they or full outer orbits, but now that they're charged, they will bond with each other. And we know that when sodium and chlorine bond with each other, they react and we get a new substance called table salt. So when they lose or gain a electron, they get a positive or negative charge. And when a atom has a positive or negative charge, we call that an ion. So when sodium lost its one electron, it became a sodium ion because it was positively charged. When the chlorine gained the electron, it gained a negative, it became a chlorine ion. So this is when electrons are gained and lost. Only electrons can move back and forth, not protons and not neutrons. Now, if a particle gets a positive charge because it's lost electrons, it's called a cation. So that was like sodium. It lost electron, so it got a positive charge. So that sodium would be a cation. And the chlorine had a negative charge because it had more electrons now, so it's called an anion. Noble gases are stable because they have a full outer orbit. So that is that. They're not gaining or losing. And other atoms achieve a full outer energy level and more stability by losing or gaining electrons. So I talked about chlorine and sodium already. So we can see here that sodium, 2 in its first orbit, 8 in its second orbit, and it had 1 in its third orbit. It wants a full outer orbit. So if that electron jumps over here to chlorine, that third orbit disappears and its second orbit is full. Chlorine, as we know, had 2, 8, and then 7 in its outer orbit. It just gained 1. So now it has 8 out of 8 in its outer orbit, making it a full outer orbit. So it's happy as well. Sodium now has one more proton electron, so it gets a positive 1 charge. Chlorine just got an extra electron, so it has a negative charge, and they attract to each other, and we get NaCl, sodium and chlorine. You notice down here that sodium ion is Na+. That tells us that sodium, when it's neutral, is Na. When it is in ion form, it has a charge, it's a plus, where chlorine in ion form is a negative. And because this is only a +1 and a -1, you can either just leave it as a plus or you can actually write +1. If it was a +2, which would be an alkaline metal, would be a +2, then you would write +2 up there. So what ions would oxygen and aluminum form? So ionic compounds. Ionic compounds are where we have atoms that are negatively and positive charged ions joining together. And iron oxide is an example of that as well. Now, just to look at the periodic table here, remember we have our staircase. All these over here are metals, these are non-metals. Ionic compounds are always between a metal and a non-metal. So sodium and chlorine, and you get table salt. You may get lithium and oxygen for lithium oxide. Potassium and oxygen, and you would get potassium oxide. The bonding that we talked about today, ionic bonding, ionic meaning that it's bonding between two charged particles or two charged atoms. One will always be a metal, one will always be a non-metal. If two non-metals bond together, that's not ionic. And two metals are not going to bond to each other or react with each other as well. So always a metal and a non-metal.